Good afternoon, everyone. Again, my name is Brad Walter, and today we're going to be discussing a flight scenario where you checked out a light twin aircraft from a local flying club, and you're going to be flying it from one state over state lines to the next state in an area that has some rolling hills going on. So for this scenario, I picked my original hometown, upstate New York, the Binghamton General Regional Airport, and flying down into Pennsylvania. Alright, for this flight scenario, you have a minimal amount of time in light twin aircraft, and actually no time in the make and model that you're checking out from the flying club. But we're assuming that you're current and able to legally check this airplane out. So you're going to be checking it out and flying from KBGM, which is Binghamton General Regional Airport in upstate New York, and flying to Grand Canyon Regional Airport in Pennsylvania, N38. It's approximately a 70 nautical mile flight, and your destination or your departure airport has a field elevation of 1,638 feet, and destination is 1,892 feet. Along your route, your ORCA or off-route obstacle clearance altitude, the maximum per the charts for this flight is about 3,100 feet, and that ORCA provides you with 1,000 feet of clearance above any obstacles or mountainous terrain below you. So there are some hills along the way for this route, but nothing crazy high in elevation. It's a beautiful summer day up in the Northeast, and your destination airport has a runway 1028. It's 3,597 feet by 60 feet. So it's long enough and wide enough for the plane you're going to be landing there. Based on the chart for the Piper Seminole that you're checking out from the flying club, has an accelerated and stop distance of 2,800 feet for a nice summer day of 24 degrees Celsius. So you have enough runway. It is kind of a short runway, but you do have enough to be within that range of your accelerated stop distance in case you have an emergency right before you go to takeoff. Unfortunately, on this beautiful summer day in upstate New York, you ended up having an engine failure. So for this scenario, we're going to assume that you did your initial emergency procedures. You maintained directional control, kept the airplane flying, pitched for your VYSE, or blue line, and executed all those procedures that you needed to secure that engine, and then you did all your troubleshooting, and turns out you were unable to get the engine running again. It completely failed on you, so now you're stuck flying the plane single engine. So how do we maintain directional control? We're obviously going to have to put a significant amount of rudder in and raise that wing, raise the wing of the dead engine to maintain your directional control. And the goal is to not be in a side slip, because if you're in a side slip, that's going to create more drag and decrease any kind of climb performance you might have. Another thing that's going to increase drag is if you have a propeller out there that's windmilling. So again, you went through your emergency procedures and got that engine secured properly and feathered it, so your drag should be minimal from that. Also want to consider your landing gear and flat position too, to decrease drag depending on how far you need to fly the plane. Single engine maneuverability, it's going to be obviously a little bit more difficult. You're going to want to minimize your angle of bank for turns and stuff like that. You can still fly the plane safely as long as you maintain a good airspeed. Just want to be cautious when you're, especially when you're dipping that dead engine down if you're turning into the dead engine. Alright, and here's a little bit more on that engine out performance. The chart from the POH for the Piper Seminole. You want to raise that wing of the dead engine 2 to 5 degrees, and your goal for raising the dead engine and putting in your rudder input is you want your ball about half to 3/4 out, and based on those inputs, that should put you in the best, put your aircraft in the best position to maintain a straight line while not side slipping through the air. So the more you're side slipping, the more drag it's creating, and it's going to decrease your airspeed and your any kind of climb performance, or if you're at a high enough altitude, your single engine rate of descent will be increased too if you're side slipping. So based on this, if we're at about 2,000 foot pressure altitude, you're looking at about 190 foot per minute single engine rate of climb. To wrap things up here from the scenario, obviously it's super beneficial to know the engine out flight characteristics of whatever plane it is that you're flying. Make sure you review those thoroughly. In this scenario, you're flying a plane that you've never flown before, so you definitely want to make sure you read through the POH, make sure there's not any unique specific procedures to that airplane that are different from the one that you're used to flying. Make sure you have your route of flight planned out and you study it. Know what obstacles you have along the way. Know your highest elevations and alternate airports too, in case you do have an emergency like this. Always run your performance charts every time. Calculate performance. No matter how many times you've flown out of the same airport or flown the same airplane, just make sure you're running those performance charts every time to keep yourself safe and don't run into any unneeded surprises. And here are the references that I used to put this PowerPoint together. I hope you all enjoyed. Thanks.